All right, for this video we have a huge topic to talk about, and that's the topic of functions. But before we can really talk too much about functions, we first have to talk about a relation. A relation is really just a connection among two collections of things. So there's all kinds of different relations, and they tell us how those things are connected. But you might imagine maybe connecting a person to their parents, or maybe a person to how many animals they own. You know, it's just really saying how we should connect two collections of things. So with that idea out of the way, then we can move on to a function. Now, a function is actually a very special type of relation, so it also tells us how things are connected. The key difference for a function versus just a generic relation is that in a function, we look at the inputs and outputs, and every input is connected to exactly one output. So in this case, it's a little bit more restrictive. But definitely keep in mind that a function is really just a special type of relation with some restrictions on what the inputs can actually be connected to. To get a better sense of this, we're going to look at a couple of functions and see that they really are functions. All right, so let's look at this first one. So really we just want to see if these are functions or not. And since this is math, we're going to look at collections of numbers. So here I have a whole collection of x's and a whole collection of y values. And we're going to check each one to see that it's only connected to one y value. All right, so going down the list, we see that 2 is connected to 2. That looks pretty good. 4 is connected to 5. That's also pretty good. And 6 is connected to 3. So there is no instance where, let's say, 2 is connected to two different values. Everything is connected to one value. So we can say that, yes, this is a function. Moving on. Here, 1 is connected to 7, 3 is connected to 4, and 5 is connected to 4. Be careful. If you're looking at that last row going, wait a minute, 3 is connected to 4, 5 is connected to 4, is this an example of not being a function? Unfortunately not. This actually is still a function because every x value over here is only connected to one y value over here. So it really does maintain this function relationship. All right, one last one. Let's look at this guy. So here are all of our x values, and we're seeing how they're connected to the y values. So 8 is connected to 7, 6 is connected to 4, 4 is connected to 9, and 4 is connected to 5. That last couple of rows, those are definitely a problem when it comes to a function. And the reason why it's a problem because this is the first instance we've seen where 4 is connected to two different values. And that really is an issue, so this is not a function. All right. Now, functions in themselves are really just a concept of how we can connect two different collections. And because they are this concept, there's many different ways that we can actually represent a function. So here's just a diagram of some of those ways that you're definitely going to see when going through mathematics. One of the first ways you could really see if something is a function or not, or really just those connections, is in a diagram. In a diagram, we would list out the different x values and specifically see how they're connected to those y values, either using an arrow or something like that. In a very similar fashion, we could use something like a table. A table, again, just lists out various different x values, and the other side of that table tells us what they're actually connected to. Definitely very similar to a diagram, and it uses that x and y notation in there, inputs and outputs. A very popular way to really show those connections if there's lots and lots of x and y values is to simply use a rule or an equation to make those connections. So this is quite different than those other two representations, but it's still a way that we can represent a function. Here you might imagine some value for x, so you could say x equals 3. You'd plug it into the equation, do those calculations, and whatever you get out becomes the y value. So let's see, if I were to take 3 squared, that'd give me 9. 9 times 3 is 27. 27 minus 1 is a 26. So this would give me a y value of 26. So that tells me that 3 is connected to 26. And again, the equation just gives me that rule or those connections. All right, let's move on. We can do a mapping type method. This is one of my favorites because it is very visual. Here on one side, the left here, we have all of our x values. And over on the right side, we have all of our y values. And we literally use arrows in between those two so that we can see how they're connected. It's a little bit different in, say, the diagram or the table, in that sometimes these arrows could go diagonally or even quite far away. But we can clearly see that 2 is connected to 3, 4 is connected to 2, 6 is connected to 5. We clearly have those connections. All right, and another good way to represent a function is by simply looking at its graph. Here, the inputs and outputs are really along the axes. So I have my x-axis and y-axis. Every little point that I pick out on the graph is really an ordered pair of those x and y values. Well, so let's see. It looks like I've picked out the value where x is equal to 3 and y is equal to 2. So I know that 3 is connected to 2, and that looks pretty good. Now, if you want to know if something is a function or not, you don't necessarily always have to go back to that definition, every x value connected to a y value. Instead, if you have a graph of that function, you can apply what is known as the vertical line test. This is a really quick and handy test to see if those inputs and outputs are really satisfied in that definition. And the way this works is you look at the graph of the potential function, and you draw a vertical line anywhere on that graph. If it so happens that that vertical line goes through more than one spot, then you know it is not a function. If no matter where you put that line, it only goes through one spot, then it is a function. So as a good example of this, here I have two different graphs. And you can see that I've put on a nice little vertical line, so we can see if it will cross it once or more than once. Now in this little first example here, no matter where I decide to move that vertical line, it's only going to cross in a single spot. So I know that this is definitely a function. We would say it passes the vertical line test. Here I have a graph. It looks like a sideways V, and it has a few problems with this test. Here I've drawn a vertical line, and unfortunately it crosses two different spots. So this fails the vertical line test, and we know that it is not a function. All right, and that's just a little bit about functions.
Hey guys, my name is Jess, the head of education here at Wise. I hope you enjoyed this video tutorial. If you want to see the complete course, please check out the link in the description. You can also go to one of our playlists to keep learning for free. If you want us to cover a specific course or a specific topic, please leave us a comment below. We post new videos every week, so don't forget to subscribe so you don't miss out on any of the new stuff.